Welcome, class. Thank you for coming back. Last time we talked about Wireshark and how it captured packets. We called them packet data units, PDUs. And yeah, all right. You know what I mean. Well, I've captured some packets here, and today we're going to learn to analyze them to be able to look and see what they do. Yes, Vanessa?
Mark, I know how you capture the packets, but how do you preserve them?
Good question. Yeah, thank you. LB is correct. What I do is, if you look up here, I go ahead and click on File, and I go ahead and click on Save As. Then in the File area, I put the name of the file that I've captured, and when I save it, it saves it as a PCAP file, a PCAP. Now, with that file, I can actually go find it in my directory, click on it. It opens up Wireshark and that capture. Or if I've already got Wireshark open, I click on the File, Open, and then I can choose the file, and it will open up. Okay, does that answer your question?
Yes, it does. Thanks.
Okay. Now, as long as I got you here, in this short capture right here, Vanessa, if you look in the packet list pane, what can you tell me about the source and destination column?
Well, I see that the source computer has an IP address of 172.16.0.20, and the destination computer has an IP address of 192.168.254.254. I also see that these two addresses keep switching places in the two columns, so I'm thinking that they're talking to each other, maybe?
Good job. Yes, LB, she did a great job. You're absolutely correct. Now, let's move one step further. What about the protocol column?
That's a primary protocol being used by the packet, but why is the packets show TCP, which is a transport layer protocol, and the other is HTTP, which is an application layer protocol?
You're very observant. The primary protocol being used is the one that's going to be displayed up here. Yeah, thank you, LB. LB is correct. He's pointing out that this is part of the initial conversation, the TCP packets, when we're establishing a connection. We call it a TCP three-way handshake. Let me give you an example. If I were to walk up to you and I said, put up my hand, I said, "Hi, I'm Mark Anderson." How would you respond?
Hi, I'm Vanessa.
And then, being polite, I would say, "Glad to meet you." That was a three-way handshake. I started, you responded, and then I finished it. The computers do the exact same thing. Now, if you look here, I'll show you. If you look at the first line, you'll see this bracket, an SYN. That's for synchronization. So I'm starting off, and I'm going to say, I want to synchronize with you. I want to start a conversation with you. Now, if you look at the next line has a SYN, comma, ACT. What that means is you first, ACT, you acknowledge that I want to synchronize with you, and you said, yeah, I need to synchronize with you also. Now, the third line, if you look down there, the third line just has an ACT. That means I'm responding. Glad to meet you. Also notice in the first line there's an SEQ equals 0. This is a sequence. So the next time that you get a packet from me, it should say 1. And you'll see the third line, see it says SEQ is equal 1. So every time you get a packet, you can keep them in order. Now, they won't always start with 0, but that's pretty close. Okay, so this whole process so that we can have what we refer to as a connection-oriented conversation so everything is accurate.
Well, that makes sense. It looks like the middle pane actually has a little information on it too. Does that help you explain it better?
Actually, it does. If you look at each one of those lines, it's actually based on the OSI model or the headers of the packets, and you'll see a plus. If you click on the plus, it opens up and you see more information. Now, the first line there, you'll see the one that says layer 2, actually says Ethernet, that is your layer 2 packet.
I remember this. The MAC addresses are used to get from device to device, whereas the IP addresses are used to get from the original sending computer to the final destination computer. So the source MAC address should be the last device that transmitted the packet, and the destination MAC address should be the next device to the final destination en route.
That's absolutely correct. That's absolutely correct. And taking that one step further, you just explained layer 2. If you go down to the next layer, this is the one that is, it says Internet Protocol, this is the IP, and there, just like you said, there's your source IP address and your destination IP address. In other words, original source to final destination. I'm going to slip down to the next line, which is the transport layer. It says Transmission Control Protocol. That's the one we're going to look at. First thing you notice on here is that there's things that says source port 1963, destination port 80. Port addresses are kind of like doors. So if you are a computer, Troy, and in your head you've got different conversations, you've got a door 80. My packet's destined to your door 80, and I go in there, which actually is a web server. And then when you respond back to me, I've got a door up here. It's door number 1963, and that's where those conversations going to. So our conversations between those two ports. Now I'm going to click on the plus, and it opens up, and I see the detail of the TCP packet. I'm going to go and click on the one that says flags. It opens up, and you'll see all these zeros and ones coming down at an angle. In actuality, what those are is those are bits. Now, if you look at the one that says, and let me choose a different packet here. Let's choose the second packet. This looks better. Okay, you'll see the acknowledgement has a 1, and the SYN has a 1. This would be the second packet in the conversation, because it said we had an acknowledgement when I was talking to Vanessa and a SYN for synchronize. So you can actually see more. So does that answer your question on that?
Yeah, but how often does this three-way handshake occur?
Well, that's a good question. In this situation, we're talking with a web browser to a web server. Every single web page, you're going to have a TCP three-way handshake. That's a lot of them.
Wow, how about HTTP packets?
That's right, LB. Those are basically web page packets, and let me give you a better look at those. I'm going to go and click on Analyze, go down to Follow TCP Stream. Now we have a window that shows just the HTTP packets in a row and shows the contents. It's mostly HTML packets, but if you look at the bottom, you're going to see, "Welcome to the Eagle Server Web Server!" exclamation point. What that is that's what you're going to see in your browser. Okay, does that answer your question?
Yeah, it does actually, thanks. So that's really cool. If we were looking at FTP packets, would we actually see the contents of the file being transferred?
Well, that depends. Usually not, but the format of the file will determine that. But sometimes you can. But what you can see is you can see a username and password. Here, let me show you. I'm going to go ahead and load a different capture file. I will load a capture file here for FTP. I've loaded it. And now if you look at it, I'm going to, again, it shows FTP packets. I'm going to click on Analyze, follow TCP Stream. And now it opens a window. And in this stream, you'll see it says User Anonymous. Anonymous is basically a generic username, but you could see it. But what's more important down there is the password is PASS. See that in red? You see the password. Not really the most secure, but that's why we have other utilities for security. So from this, we've talked about capturing a stream of packets, how to analyze them, and the first steps to analyze these packets and the different layers.
Wireshark seems like a great tool. I've only had my first glimpse at it, but it really seems like it makes it easier to be the packet instead of just having it as some sort of magic trick.
Absolutely. Well, that's great to hear, and that sets us up for the next time. We'll talk about more features of Wireshark. Yes, that's right.